everyone and welcome to the channel. Today we are going to discuss about the memory management in Swift. I am not going to discuss about the basics of weak, unowned, ARC. You will get a lot of videos on YouTube and a lot of content on Google for this. So what I'm going to discuss with you today is about association. How association works with the memory management in Swift. Basically, association is of two kinds. One is the aggregation and the second is the composition. You might be using this code in your everyday coding. So let's jump into the example and let's see how it works. Okay, so I'm in the code now, and what I'll do is first I'll create one class called as person, and then I'll create another class called as account. In the person, I will say, okay, have an initializer, and I'll just make a print statement here, which will say person init, and the same thing I'm going to do in the account. It will say account init. Then what I'm going to do here is I will add the dinit as well to check the deallocation of the objects. So I will say here dinit, and same thing, I'm going to copy paste here in the account. This whole thing I'm going to copy paste here. Account. Okay. So now what I'm going to do is I am going to create an object of person class, and I'll mark it as optional, and then I will initialize it. And once I have initialized it, what I'll do is I'll make person as nil. So let's check out when I make this person nil, what happens. So you can see the person is first initialized and then it is deinitialized. The account did not get called because there is no relationship or ownership. So what I'm going to do here is I will create the account of a person. So I'll say account equals to account. Okay, so now the person is holding an account. So let's see what happens now. You can see the account got initialized, then the person got initialized, and then the person got deinitialized, and then the account got also deinitialized. So this thing worked very well. So let's check in the by debugging it what happened in the background in the memory. Okay, so I'll put the debugger here, one here. Okay, let's debug it now. First, the compiler is going to come here. I'll create an object of a person. It will go into the person class, but first it will encounter the account object. So from here, it is going to move to the account object. It will initialize the account object. Once the account object is initialized, you will see it has got a memory address, which means the ARC count goes up by 1. Okay, so now we are in the person class, and once the person class gets initialized, you can see the person also got a memory address, and then this also makes the ARC count increment by 1. So now we have the ARC count at 2. If you notice here, the person is holding the account, and they both of them have the different memory addresses. So they are not pointing at the same memory address. Okay, so what will happen now is if I say person equals to nil, let's see where it goes. It comes to the deinitialize of the person first, and it deinitializes it. And then it goes to the account as well and deinitializes it as well. So you can see that once the person became nil, the account also went nil. The reason behind this is because account has got no reference left which is pointing to it. the person was having the ownership of the account. So when the person got deallocated from the memory, the account did not had any memory reference left. Let's see in the memory graph the same thing. I'll run it again. Okay, I'll pass this. Okay, this is, you see here, this icon, this is debug memory graph. Let's click on this, and then you come this side and you point to the person. You can see the person is pointing to the account. It is holding the account. So once this person gets deallocated, the account has no reference left pointing to it, and which is why this also gets deallocated. So what does this prove? This proves that person has the ownership of the account class. So this kind of association is called as the composition, where the parent entity holds the child entity. Okay, so let's have a look at the another type of association. So I'll use the same example here. I'll make a little bit of changes here. So instead of initializing the account, I will say that person holds a variable of type of count, but it's still not initialized. And account holds a variable of type person, and it is still not initialized. Okay, so like this, I will create for account as well, and let me run this and see what happens. So if you run this, everything goes fine, because you see person got initialized, account got initialized, and then both of them got deinitialized. The reason behind, because they were run as a separate entity. So separate objects were created, and there was no relationship or ownership between person and account. So let's create a relationship here. So what I will say is person's account should be this account, and account should be associated with the person, which I just now created, this one. Okay, so now there is a relationship that person is having an account of type account, and account is having a person called as person. So let me run this. You would notice that the deinitializer did not get called. The reason behind this is whenever a person or any object is initialized or any reference is created, so by default it's a strong reference. So here person is having a strong reference to account, and account is having a strong reference to person. So both of them are holding each other tightly as a strong reference. And even if we release the person and account from the memory, still these references will remain. To prove this, let me show you this example. Okay, let me do this. Person equals to nil, and then I would say account equals to nil as well. Okay, and yeah, so let me have a print here. It is a very strange way to stop the debugger, but it works here. So let me run this. You see, I made the person as nil and the account as nil. Both of them became nil, but still they have the references. And I will prove it to you how. Let me debug this again. Okay, so you see person has a memory address, and it is holding an account which has a memory address, this one. And this is the memory address of this object. Similarly, account is holding a person account which has a memory address, this, which is the memory address of this object. So both of them are holding each other. So even though I make them nil and they show as nil here, I will show you they are still existing in the memory. For this, we can use the profile. Maybe first I have to stop the build. I'll clean it. Let me go to the profile. Okay, here I'll select the leaks and then I'll run this build. It's running. You can see here, I'll just pause it. There is a memory leak and there are two new leaks. If I click on this, you will see that the person is still existing in the memory and the account is still existing in the memory because they are holding each other as a strong reference. So this proves that even though I make this as nil, still these references remain in the memory. So how do we stop this thing? So just consider that this is the parent class and this is the child class. So either of them you can make as a weak reference, but the best practice is always to make the child as weak. Okay, so now when I make this weak, so now they both are not holding tightly to each other. So person has a strong reference to account, but account has a weak reference to person. Okay, I will show you one more thing here before I step into this. Okay, let me run this. Go here and let me go to the debugger graph. Just notice how it is looking right now. Account is pointing to person, and when I go to person, person is pointing to account. Okay. So let me make this as weak now. Okay, so now person is having the strong object to account, but account is pointing as a weak to person. Okay, let's run this first directly. You would see that the initializers and de-initializers both are called. So this works fine. And let's have a look at the debugger graph. So I'll run it again. I'm sorry, I have to stop it here before making it nil. So I'll run this again. Okay, now let's look at the debugger graph. So you would notice that account is holding a weak reference storage. And if you go to the person, which is the parent class, it is holding an account, but it does have the Swift weak reference storage. So this is the difference. And that is the way how we have broken the strong reference cycle. So this kind of association where person has a type of account and account has a type of person, there is a relationship between the two classes, and that kind of relationship can be called as the aggregation. So this was all about the memory management for association in Swift. For this video, I was considering that you already know the basics of weak and unowned and ARC, and which is why I did not went deep inside into those concepts. You let me know if you want the video on weak and other ARC concepts. Let me know if you like this video. Please comment and subscribe, and thank you very much for watching this video.